Yeah, so welcome to session 5. Today is going to be, we're going to cover physics and collisions and also like review sprites. So the sprites are basically um, any sort of like, I like to think of them as objects in Pygame. So um, let's see. Mm, yeah, well, I guess it's pretty self-explanatory, but it's just like something in Pygame that makes it easier for us to draw and update stuff. So not really much to see here. If you need to like go back, there's a slide here. So it's like, okay, you want to make sure you have this Pygame parent class so that it inherits like the update and draw functions as well as like the main things that the spray function allows you to do is like it's the image and rectangle. So the rectangle helps you with um Pygame collisions, I believe. Actually, no. Sorry, the rectangle and image are just both used for drawing onto the screen. So that's like the main thing Sprite does. If you really want, you can implement it yourself, but I mean if the parent class is there, just use it. Okay, so this physics thing is like for anyone in high school, if you've done like physics 20 or above, you probably will have learned this already, but the point is that like physics is basically in a game, it's basically makes like everything more realistic, right? So it's like collisions and projectile motion and stuff. Um, I'll try to go over this pretty quickly. So usually what we call like the amount that an object changes, well, basically an object speed, we usually call it velocity, which is basically speed with the direction. So that's why usually you'll look at like the more official term is generally like x velocity, and that basically means the velocity is speed with the direction, right? So you can be if you're moving right, then your velocity is like 3. If you're moving left, then it's -3. Same thing for y directions. Mm, like why would we want to use like something like a velocity variable? Well, like first of all, then you can adjust it, right? So every time you change this, it's like zoom, the ball will go faster if you set it to 5, whereas if you set it to like 0.5, it goes slower. But the other thing that you can do is you can add something known as oops, wrong slide. Acceleration, right? And acceleration is basically the change in velocity. So I mean, most of you have experienced this in, say, like when you're driving and you speed up, right? You're on a roller coaster and you go down the roller coaster like you're speeding up. So that's basically acceleration. And so how you do that is you basically change the speed by a constant value, which is the acceleration. And it results in the effect of like speeding up, right? So you can see over here, here's your acceleration value. We call it like gravity because that's basically what stimulates. And every iteration of the frame, like your y speed moves faster, right? So actually, I'm not going to draw a diagram, but if you just imagine like at first, each frame the ball moves like 1, right? Then the second frame the ball is moving 3, and then the third frame the ball is moving like 5 or something. So each frame, since the ball is moving a longer distance, it looks like it's speeding up. Okay. We're not going to go over the physics. If you really want, you can look at this slide. Okay, so the first question is, what do you need to basically add to the code to make this acceleration work? Hmm. Yeah. Okay. And I'm going to go into Top Hat. I'm going to stop screen sharing for a moment in case I somehow give away the answers. So does everyone get set up? And I should be good in a minute. Uh, Question 5. And oops. Okay. Let me screen share now. Ready? So now I'm just gonna give everyone like, I don't know, 30 seconds to enter the join code, and we start. That's not sure. I think we should have 7 people answering the. Let me think. Okay, I only have 1 answer so far, so I'm not really sure what is going on. I'll add 30 more seconds. Huh. Is anyone else having the same issue? Okay, now we have 2 answers. Kaylin, did you get it to work? Okay, now we have 7 people. It's good. But I'm just gonna extend the time. Okay, that's good. Okay, 20 seconds left. Okay. Just gonna let the timer tick down. I assume I just click on responses, but okay. I see. Oh wow. Okay. So I think this is like a long answer. Short. What is this? Like a short answer thing or something? I did not make the question. Here, I will quickly go over like what the so-called solution is, and then and I'll just go over each of these and kind of say like whether it's correct or not. Well, I guess the main thing that you really need is you just need, like we saw on the earlier slide, how y speed is changed by a constant value. That's how you add the acceleration, right? So that's basically the exact code that we were looking for. If you typed anything along those lines, we can count it as correct. I'm not exactly sure how Flare marks it. But this is what we would be looking for. So it's basically like without this line of code, right? Then y speed, well, the speed that the ball moves at is always constant. So add gravity to speed variable. Yeah, that's correct. I feel like we should make this a multiple choice question. Uh, this is correct as well. Um, correct. Okay, so we're not actually multiplying y speed by the acceleration. If you actually multiplied y speed by acceleration, then it would be getting slower by a factor of 0.8 every single time. So we have to be careful about that. Um, if you made like gravity, what's the word? If you made gravity like larger than 1, you could multiply it, but then the acceleration is not constant, right? So it would actually be I'm not exactly sure how the physics for that would look, but it wouldn't it would probably look kind of wonky. So yeah, so this. Yeah, that's 5. Um for whoever put that they don't know, now you know it's you add a constant acceleration. Um okay. Now we're just gonna quickly cover like jumping because it's a pretty common mechanic. Okay, I'm screen sharing, that's good. Okay. So how jumping works is you just set like a velocity. So it would be a negative velocity in terms of y. So it's like, um, because you know how the coordinate system, the 0, 0 is in the top left, right? So that means if you set the y speed to negative and Mario starts like down here, for example, then each frame he's gonna move up like some num around 10 pixels. But since gravity is acting on the speed, eventually he's like stops moving upward because the y speed gets to 0, and then eventually he'll start shifting direction, right? Um, I didn't implement the full code for this, but I did implement like example of gravity over here. You should be able to see a whole screen. Basically how it looks is what I think there's a question based an exercise based off of this as well, so I won't like show my code for too long, but the idea is that you create like a rectangle or something which you can add some velocity to. You initialize like a y velocity of gravity, and then the way I do it is I define might not actually be the most effective way, but you do want to have like a jump and gravity function. I'm not sure about. I don't think you should have to use global y velocity. You might have this like in a player class that we don't have to like global the y velocity, but I'm just making like a quick example. So basically how it works is if the player is like player dot bottom, so the bottom of the rectangle is touching this bottom of the screen, then or not touching. If it's smaller than bottom of the screen, so it hasn't touched the bottom of the screen yet, then increase the y velocity with gravity. Otherwise, set the y velocity to 0. And so if you rerun the code here, you just have also you run these two functions here, and then you make sure that every frame the player's y coordinate is moved by its y velocity, and then you draw the player here. So yeah. If I wanted, I could add code to reset the rectangle, like so that's bottom is touching the bottom instead of like falling through the screen. But how jumping would look is I guess there's a couple of things you need to consider. One of them is you want to have like a jump cooldown, and you want to have a check like whether the player is actually on the ground or not when you are able to jump or not. But the simple version is you literally just have some function that's like, okay, if some key is pressed, then set the y velocity to whatever the jump velocity is. That's like simple version. And so what we want to do is make a rectangle that is constantly influenced by gravity, and then whenever you press the space key, it jumps. So as you can see, there's some bonuses here. There's these two. And there's also you add like a terminal velocity, which basically maxes out the speed at which the bird can fall, so it doesn't like just start jumping like 100 pixels at a time, which usually it never happens. But something you'll notice is if you don't have the like a jump cooldown or something, like a jump you can do what you can make it based on when a player touches the floor. You can also make like a cooldown. You can only jump every X seconds. And if you're like able to keep pressing the jump key and constantly reset the Y velocity to -20, usually what happens is the gravity. Um, hang on. Actually, no, that doesn't apply in this case. Sorry. Um, yeah. I think there are some cases where let's see. Y speed, gravity. Yeah, no, ignore what I said, but if something weird happens with your code because you don't have like infinite if you have like infinite jumps, sometimes you will have strange behavior as expected. So we can do like 20 minutes for this exercise. Like your main thing is the gravity and jump, and then you can figure out the other stuff afterward. Okay. Um, oops. Okay. So now we're gonna do collisions. Um, at the very least, hopefully you are able to implement the gravity and the jump. If not, you can work on that in the next breakout room and definitely ask your mentor if you haven't figured it out at this point. Um, all right, collisions. So collisions are basically when two sprites overlap. It's pretty simple. Like examples, platforms, bullet and enemy or player. And whenever a collision happens, you usually want an effect to happen. Um, I think this stuff is pretty self-explanatory. So usually, the most common example of collisions is obviously like I would say like boundaries, and then also if there's like power-ups and stuff in specific games or like enemies, like projectiles hitting enemies, those are pretty common as well. Mm. The most common way to just detect collisions is you can use Pygame's built-in function, which basically takes two rectangles as a oh wait, no, sorry, sprite collide just takes two sprites as arguments. So in this case, you would make like a player sprite. I'm pretty sure you would have to use the pygame.sprite.sprite class. That's why you inherit from there. Um, hang on. I'm gonna quickly look this up. Wait, no, never mind. Okay. Um, okay. Yeah, skip. Yeah, so basically it returns like a true or false. And so the example here is like if we want to like stop the platform falling, it's like if the Pygame player and platform sprites are touching, then have the player set their Y velocity to 0. Um, Obviously you actually want to check like whether the player is coming from the bottom or the left or the right. But since there's only like one sort of collision in this example, then it's okay to do that. So here's a quick question. I'm going to go and look at that quickly. Set it up, sorry. So everyone, like you can get Top Hat set up and get the code ready. Mm, yeah. Oops, sorry. Yeah, so whenever you're ready, you should be able to join. I think we should have a total of 8 mentees. If you're having trouble joining, just mention something in the chat. I'm just gonna look at something off to the side. Don't pay attention to that. Yeah. Okay. Okay. Actually, how? Dude. Yeah, okay, I need to go back and mark these thingy-majiggies. So yeah, basically the enemy switches direction. That's what times equals. It's basically like it basically means enemy dot x underscore enemy velocity equals enemy velocity times negative what? Yeah, times -1. That's the shorthand times equals. And so the speed, when it's multiplied by -1, it switches directions. All right, because if you think of like, if a positive number is moving to the right, then once it switches to a negative number, it's moving to the left. If you multiply by -1 again, it switches directions again. Okay. So yes, enemy opposite direction. It's multiplied by -1 and the number gets updated. So, I mean, this is technically correct, but to be fair, the question is not too specific, but I think we want the question is looking for like what does it do in terms of the game. Um, left to the left is not necessarily to the left, it just switches direction, so it depends on which way it was going. So this, yes. But negative doesn't actually stop the speed, right? So if your like speed is 5 or something and you multiply by -1, it's just -5, so switch directions. Okay. Hmm. Anyways, for everyone who said that it switches directions, you're correct. For the other ones, I'll look at them more, but for this one, yeah, I would say correct, but like there's nothing saying that the wall is on the right, so because if you look at the code, right, just as enemy.speed, like it's kind of like a logical bias because we're used to like a player, say Flappy Bird's always moving right, or it looks like that. So, but there's nothing about like the direction that starts at. Because the enemy speed could be negatives to start, and it would be moving to the left, and then when you multiply by -1, negative number times negative is positive, right? Anyways, uh, I'll go back over this later. And so basically, moving on for collisions, what we're gonna, I'm still screen sharing, am I not? Okay, that's good. So for checking for multiple collisions, you basically have like a for loop, simplest way. Um, Dude, okay. This is like it's actually bad code because obviously you're like, oh, what if you collide from the bottom? You don't want the y speed to be 0. Um, oops, sorry. And something else that you can do with for collisions is there's a sprite.kill function that comes with the Pygame class as well. So what it does is it basically deletes the object completely, so just like erase from memory. That way, like if you have like some platform, usually not platform, but if you have like a bullet in a list and you want it to stop taking up space after it collides with the player or like or some enemy, and obviously you don't want it to keep like moving through the enemy unless like the point is to have a penetration, but then you would just dot kill is a pretty good method to just erase it. Um, this is like a question, food for thought. Wait, what is this? It might have been me. Food for thought, basically like what sprite do you kill if a player hits a coin instead? I'm just gonna answer. Obviously, it's the coin. Like, um, let's see. I believe this is a resource that I meant to put in this slide. Yeah, so basically it brings us down to our exercise. Yeah, okay, this is the one. So what we want is we want you to add platform and collisions to your player. So you should be able to just use your session 4 exercise, but if you for some reason like weren't able to get it to work, then just DM your mentor and they can go into like the database of question exercise solutions and they can send you the code. Otherwise, you should your platform your session 4 code should be fine to use, or session 3, I think. Whichever one you have player and platforms in. And yeah, make sure you use this platform.py file. Remember to rename the platform.py file to like platform2 so you don't have any naming conflicts. There's a couple of bonuses you can add. This thing is 50 ignite points. Okay, I'll add the point value later. But the last thing that I want to mention is you should check out there's actually 2 resources that I recommend for just like doing collision. So this one is the method that they use is that you have like a rectangle. The rectangle that you pass into the collide rect function is well actually you don't use sprite.collide. You use like pygame.rect.collide, something like this. And what you pass in is what the rect player's like location will be. So you basically player.x plus. You can actually look at the YouTube link, the link that I sent. Also, the channel is good for a lot of other things like game design related. If you're looking for something specific, it might be harder to find, but if you just want like exploration and general like find out cool things you can do with Pygame, definitely check out that channel that I sent in the link. I sent the specific video for the collision, but anyways, the way that they do collision is like you check for where the player will be, and so you kind of like draw a rectangle for where the player is going to be, and oops, yeah, and then using that, you decide like, okay, where should I stop the player from moving, or should I reset its what is it called, velocity to, like, should I set the player's like head to be where the bottom of the platform is? Because the other method is you wait for the player to collide after it's collided with a platform or rectangle. And the issue with this is if you have like a very like, you know, a very high velocity, then the player is going to end up like in the platform for 1 frame or something. And then it'll pop back out, which like it looks bad, first of all. And sometimes if your player goes like too far into the platform or something, you'll have like weird things where the player, like maybe you're moving into the platform from the right, but suddenly it teleports on top of the platform. So that's why you want to like be careful with when you use, if you're going to check for after a player's already collided, then it's not the best method. That's why I recommend checking out the YouTube video. There's a link over here in the exercise speaker notes. Alternate method of collision. I recommend implementing this one. Especially like in your game, you're probably gonna want more than one direction, right? So you can't just like set the player's wide velocity to 0 whenever it touches a platform. Otherwise, you might like touch the side and like float in midair. Um, uh, there might be one more method. I can send it like after our breakout rooms if, yeah. But this is one I recommend. But you do, to start, you can like experiment, do your own thing. But if once you're gonna like code your game, you definitely like check out the method of figuring out where the player is going to be instead of like waiting for it to collide. And yeah, then we just have the rest of session. And if you want like images, you can go into this link in the speaker notes. Yeah, okay, I sent the link in chat. So one last thing. Okay, one last thing in terms of collisions. So what I mentioned earlier about the type of collision, there's actually the way that you want to do collision so that it's bug free is you want to use the velocity. So actually, I'll quickly go over it here in this example. Not relevant. I put the link in the session speaker note, the speaker notes of the last slide. I'll send it here as well. Basically, the important thing to note is over here, right? So whenever we have a collision with a wall segment or any, it would probably be the platforms, right? What you want to do is you want to check which direction that the rectangle is moving, and you notice it's all if statements, none else if. So this is saying if the rectangle, or sorry, if our player is moving right, and it's collided with a rectangle, then it's some part of it's hit and you can like reason through this in your head as well. If it's moving right, then it's hit the left side of the platform, right? Here, let me see if I can get an example. It's like if the player is moving right and it's collided with something, then it had to have collided with the left side of whatever it is, right? Because no other, like we're assuming that you can think of each of the checks like independently, right? Okay. Anyways, basically what you want to do is you want to use the velocity that the player is moving, like the direction that the player is moving in to determine like where to re or like where to set the player's coordinates. So you can see like this code checks like if the player was moving right, then set the right side of the player to the left side of the wall. So that way there's no like overlap. So in this example, they actually do have the player they allow the player to collide with the wall. So like you'll still have that, that one frame where if you have like a really high velocity, you can actually okay now. It's like, yeah, if you have like a pretty high velocity, your player might end up for a frame inside the platform, but for the most part, it's not an issue. Um, but yeah, so basically use the velocity. I don't have an example of like what not to do right now, but I know there are some approaches out there that are based like purely on the position of the player's rectangle in relation to the platform, and you don't want to do that. You want to make sure you use the velocity so that way you know which direction the player is coming from, and that way you can push the player back to like where they're supposed to be. So for example, if the player's like running into the wall from the left, now you know you just have to push it back to the left since it was going right. And like it works from multiple directions, right? The player's moving like towards the corner and top left. You can reason this out in your head, but basically it will push it up and it will also push it back out to the left. Yeah, that's that. The the other one works similarly, but you actually, like I said, you use a rectangle to represent where the player will be, and then you're like, okay, well, if the player is going to collide with the wall, let's just set the player's like edge to the wall's edge instead of letting it appear inside the wall first, basically. And yeah, that's that. So you're free to go now.